In the quiet of a midnight lab, one click becomes a fact. And with that fact comes a whisper of warmth. It's easy to miss, but it's always there. Whenever the universe writes something down, it pays ever so slightly in heat. Tonight we follow the bill. We begin with a mischievous thought experiment. Imagine a tiny gatekeeper perched between two rooms full of gas. The demon watches the molecules. Hot, fast ones go right. Slow, cool ones go left. Soon, one room warms, the other cools, and our demon seems to have built a temperature difference from nothing. Free energy, a cheat code against the second law of thermodynamics. So what's the catch? The catch is the clipboard. To sort the fast from the slow, the demon must know which is which. It must store those decisions, even briefly little ticks in a memory. And when the page is full, the demon must clear it to keep going. That clearing, that erase, is where the bill arrives. You can juggle bookkeeping tricks as you please. But when you truly wipe information, when you make a many possible memory into a single clean slate, you pay the universe in heat. In other words, there is no knowledge without a ledger. Sorting, deciding, filing, these are not abstract acts. They are physical processes that leave physical scars in the form of entropy and warmth. The demon never beat the second law. It just hid the cost in the eraser. Now zoom back to our detector click, some microscopic event. One photon, one electron must become a macroscopic record. You can scroll back to tomorrow. That requires amplification. A small nudge cascades into a big signal, tugging countless electrons into motion. The process is like turning a whisper into a stadium chant. Once a crowd has taken up the chorus, unchanting it, reversing every clapped hand, every breath of air is for all practical purposes impossible. In principle, with perfect slowness and care, some copies of information can be made with vanishingly small heat. But erasing information has a hard floor. Cleaning a memory to forget is an intrinsically lossy move. And in the real world, we also need records to be robust, to stand up to noise, temperature drift, and cosmic rays. Robustness means redundancy. Redundancy means extra copies. Extra copies mean more degrees of freedom involved and more heat spilling into the surroundings. So the measurement chain, sensor to amplifier to memory, has an arrow. Tiny, reversible ripples at the start. Loud, irreversible outcomes at the end. A fact is not just a number, it's a record. Stable, redundant, and retrievable. That stability is bought with physical work. The ink sets, the charge on a memory cell settles, the magnetic grains on a drive line up. Reversing all of those alignments down to the last molecule would mean undoing a vast swirl of microscopic motion. The universe knows how to go from tidy to messy in a million ways. It knows almost none to go from messy back to that exact tidy. This asymmetry is why facts feel like they only ever accumulate. Yesterday's photo sits on your phone, today's gets added. Diaries filled from blank to written. We can forget, yes, but forgetting is its own physical action, with its own heat. We often talk about time's arrow as if it belonged only to exploding stars and cooling coffee. But it threads through every act of observation. Each time we translate possibility into a record, we push a little heat into the world and take away a little ambiguity from our notebooks. The universe gets microscopically messier. Our story becomes macroscopically clearer. Stand in a data center and you can feel it on your skin. Billions of bits being written and erased each second. A planetary memory palace, humming with narratives paid for in warmth. On a smaller scale, your phone grows slightly warm as you record high-speed video. The sensor counts photons. The processor organizes them into frames. The storage locks them down. Knowledge is not free, it is engineered, and the engineering glows. Engineers have grown clever at peeking without poking. They cool sensors to hush random jiggles. They use trick light that's quieter and just the right way. They design amplifiers that dodge certain kinds of pushback. All of this can lower the cost of looking, sometimes astonishingly so. But the lower bound remains. Erasing information like resetting your counters, clearing your notes, still writes heat. And the moment you decide to promote a fragile quantum whisper into a stable many-copy headline that others can read tomorrow, You're choosing a path with a thermodynamic toll. You can make that toll small. You can move it elsewhere. You cannot make it vanish. Even ideas have footprints. The aha that jumps in your mind was carried there by neurons firing, ions pumping, calories spent. A telescope's revelation and exoplanets wobble. A distant merger's chirp travels through miles of fiber, racks of processors, and finally into a human archive. At each stage, the same quiet economics unfolds. Copy, amplify, stabilize, pay in warmth. There's an austere beauty to that honesty. Cosmos lets us ask questions, but it charges for the answers just enough to keep the books balanced. That balance is why perpetual motion machines remain in sketches, and why memory is precious, and why deletion is an act, not an absence. Let's clear a couple of myths. First, observation is just looking. No, observation is writing, creating a durable pattern that other systems can read. Second, a perfect measurement could be free. In practice, robust measurement needs amplification and redundancy. And erasing the intermediate notes has a fundamental heat cost. Third, the arrow of time is cosmic, not local. Well, actually, it is both. Every saved file, every logged particle track, every tick of a clock leans in the same direction. From atoms to archives, observation is more than a window. It is a tool that reshapes the world ever so slightly to make room for a fact. The reshaping is paid in heat. The heat is small, but it is honest. It is the signature of reality admitting this happened and arranging itself so that many witnesses may agree. Fundamentally, observation is work. To make a fact, the universe spends energy and writes heat.